In this segment, we are discussing a problem again from the state of stress. The problem goes like this. Um, at a given point, say P, let me denote it by P. Okay. Given point P, two states of stress are superimposed. One is this, so say state 1, and this is state 2. Now these two are superimposed at the same point P, and we have to find out the resultant stress and basically the principal stress and principal planes corresponding to this superimposed states of stress. Okay, now for that, and then we are supposed to do that calculation using Morse circle. Okay, now let's say we think about this state 1. As we had discussed, it's a pure shear case, right, of 8 KSI. So now if we think of say the directions like here, suppose I in this direction, so we can think that say I'll name them say AB. So the diagonal AB is under the tensile force because this and this, if you think, are trying to pull this segment apart. And similarly, if I draw say this diagonal, so C and D, so C and D is under compressive. So from there we are able to see that if we actually draw a segment like this, okay, so this will be under tensile in this direction and in this direction, and compressive in this direction. Okay, so this we had discussed while discussing pure shear case, and yeah, in fact this is the condition when we saw when we derived the relationship between E, G and nu, the alternate view. Okay, now but this is a qualitative thing, and then in fact from this qualitative analysis we also know that this tensile force is equal to this the compressive stress acting there. Okay, but let's do this in a quantitative way or using the Morse circle. Now the Morse circle for the state 1 will look something like this, right? So if we try to draw, so this side is sigma, this side is tau, then if or yeah, so if we try to draw them, so the shear stresses are say this point and this point are the shear stresses. So now tau x prime y prime, so tau x prime y prime and tau y prime x prime. Okay, and then there are no normal stresses, so that means these are the points which we will draw, and then this will become the center, and with this being the radius, we can draw the circle. Okay, this is difficult for me to draw in this yeah, this is bad, so let me try again. Say okay, and this is my circle. Then these are the values of my stresses which are acting actually in this direction, and because this is a circle of same radius, which is say, so this is 8 KSI, right? So that means this also will be so this also will be 8 KSI. and similarly this also will be minus 8 ksi. That means the compressive force is stress also is 8 ksi and the tensile also is 8 ksi. That means now we have the resultant of this in a way which is acting in this coordinate system. Okay, now we can go and calculate the actual sigma x's, say sigma x, because if I call these directions as x, so this is x and this is y. Okay, so that's why I had taken this as x prime and y prime. So now I call this as x and y. Okay, now sigma x will be 8 ksi from here, 8 ksi from this state 2 and 8 ksi from state 1. Okay, so that will give me 16 ksi. Okay, and similarly if I go to sigma y, now there are 14 ksi from state 2, right, from so this one 14 ksi, but then negative 8 ksi from here, so minus 8 ksi, so that will give me say 6 ksi. And coming to say tau xy, here the taus are 0 from state 1, so from state 2 they are 12 ksi plus 0, so that becomes 12 ksi. So with these data I can actually draw the Mohr circle for this state of stress, which is actually in a way the superimposition of both the things. And if I try to draw that, say suppose this is the axis sigma and tau, and I should if I see these two values, so the average will become how much, 16 plus 6 22, so 11, so 11 ksi. Let me draw here, so 11 ksi is the center. Okay, here is the 11 ksi point, and then what do I do? The let me write them. Okay, say sigma average will be sigma x plus sigma y over 2, so that will be 11 ksi. And if I actually try to draw, I need some space there. Okay, if I try to draw it, so what would I do? 16 and minus 12, so I should go to the point, say this is 11, so 16 and minus 12 will be somewhere here, and similarly 6 plus 12, 6 and 12. Okay, so here somewhere will be 6 and say maybe 12 here. Okay, so this is my 16 minus 12 point, and this is 6 and 12 point. Okay, now I can draw a circle passing through all these points. I mean, this being the center and these 2 points. I'll have some circle like this. Okay, and these are the points which will be my points corresponding to my principal planes and principal stresses, right? Then I can calculate, so either I can draw this to scale and I can measure these values, or I can calculate from the So the radius of this will be how much? Say radius will be the sigma x minus sigma y over 2 and its square plus tau xy square and its root, right? Because if I join this line, this angle, this length is tau xy, and um, this distance is sigma x minus sigma y over 2. So this square plus this square and the root is the radius, and I will get the value of 13 ksi. Okay, so the radius will come out to be 13 ksi, and this sigma x value, okay, the maximum principal, so I'll call this say point A and point B. So sigma A will be like sigma average plus R will be 24 ksi, and sigma B will be equal to sigma average minus R, which will be minus 2 ksi. In fact, these things directly can be read from the Mohr circle which you have drawn. And in fact, suppose I want to calculate the angles from these locations where the principal planes will be, so that you can calculate from say tan of 2 theta p is equal to 2 times tau xy over sigma x minus sigma y, and from there you can calculate theta p to be at 33.7 degrees, or 90 plus that is 123.69 degrees. Okay, so these are the values of so that means these angles you can read from there. Okay, so from these surfaces, at what angle the principal axes are lying. So that's what is these angles. That is the angle of the principal planes. Okay. So if actually you measure on the Mohr circle, you will get twice these angles. Okay. So yeah, and then these are generally the typical types of problems which you will see on Mohr circle concepts. See you in next segment with some other problem.